This training video is about the frame object. These are all frames which you see on the screen, whether they're beams or columns or vertical braces or horizontal braces or girts or purlins or trusses. They're all part of the frame object. The frame object has its own visibility setting over here. You can turn them on and off. The video is primarily about explaining what you see when you double click on a frame object, the dialog box basically. Now, when you double click on the frame object, you will see this dialog box, which has 1, 2, 3, 4, 5, 6, 7, 8 tab pages. So it's quite detailed. I'll be focusing on the first 3 primarily in this video. That is namely the geometry tab, the general definitions tab, and the detailing definitions tab. So let's start with the geometry tab. The first thing you see at the top is the profile name, which is the name of the profile. It's an IP 300. You can directly write over here. So for example, if you were to write IP 500 and press apply, that profile would change. Or if you didn't recall the name off the top of your head, you could click on this button over here. When you click on that, it opens the database. And in the database, you have this the list of all the profile types. You can open the eye profiles, for example. Inside the eye profiles, you've got all these subtypes. You can open the, for example, if you wanted the HEA ones, you could go into and say HEA 220, and in that case, that particular name would be brought to the list. If you pressed apply, your setting would be the profile would be changed. You could bring it back by just saying IPE 300 and saying apply. So that's the profile name. Right next to it is something what we call the type of the profile, and the type of the profile can be either a normal profile, which an I-beam is, or a single angle or a channel profile. They're all normal profiles. But there's another type called twin. And if I were to select the twin profile and press the apply button, you see that it changes the profile over here as well. Not just, so the twin profile, IPE 300 could not have been a twin profile. So it changes the name as well. And it also opens up another tab page over here at the top, this one. And this, if you go inside, this will give you basically all the options that you have for twin profiles. So right now what it's done is it's, let's see, it's converted that into a back-to-back angle. And what the options you have is a back-to-back angle or a back-to-back angle with short sides and long sides, or a cross angle. So for example, if I choose the cross angle and I say apply, you see that the profile over there has been changed to a cross angle. If you change it to a back-to-back channel, for example, you will see that the profile is now changed to a back-to-back channel, like you see on the screen. You have other options like face-to-face angles. That would be something like this. So, in fact, if we were to just say show only, this is what it would look like, a face-to-face angle, and the distance between the two is given over here. You can modify that distance, make it 100, for example, say apply, and it's going to open up. Let's bring it back to 10. Say apply. Similarly, you could have a face-to-face long sides, or you could have an angled box, for example. If you go like that, then it becomes a box created by using angles, and the distances between those two can be, of course, changed, like you see on the screen. And they behave as a single ID, so you can always select them and press Control Q, Control W to modify the rotations and the anchoring points, etc. So you have this option of a cross angle, for example, like that. That's 4 angles like that. These are all twin profiles. And then you have a double eye. That could be something like, you need to select something, a double eye. That would be something like this. 2 eyes would behave as a single profile. You can change the distance between the centers, or it could be a quadruple eye, could be a back-to-back angle, 4 angles to make something look like a back-to-back channel, 4 angles like that. Or I think the last option is with the long sides. So many different options you have over here, which we all basically got by choosing the twin type. Now there's another type called the built-up type over here, and if you click on that and press OK, it will basically change your single profile into a built-up profile. And you see there's another tab. This time the twin tab disappears, but you have the built-up tab, and inside the built-up tab, just like with the twin tab, you had many options. You've got 1, 2, 3, 4, 5, 6, 7 different types, and type 1 is basically an eye profile with a channel on top. It looks like this. You could press Control Q to bring it up like that, or type 2 would be a cross column like that. Type 3 would be a back-to-back channel with 2 strengthening plates all along, something like this. Then you could have type 4 face-to-face channels, type 5 partial cross from one side across rather. Then you have strengthened I-beams and strengthened from the web. And with all of these, you have their respective parameters. So these three, normally you would use a normal profile, for example, IPE 300 or whatever. But using the twin option and the built-up option, you can create multiple other types, which as you just saw on the screen. Now these are offsets out of plane, in plane, and rotation. So out of plane basically means if you select the element and press Control W, these three anchoring points from the top, from the bottom, or from the middle. These are basically the so if you say middle, say apply, it's going to come to the middle. If you say behind, apply, it's going to come to behind, like that. And then there's a further offset you can give it. For example, if you give it a further offset of 120, it's going to go another 120 millimeters beyond that. So this is the out of plane positioning. The in plane positioning is something like this, as you can see on the screen. This will depend on the usage will depend on what kind of a profile you're using. If you're using channels, then you would prefer to align them according from their backside. For example, if you're using an eye profile, the middle one will work. And the rotation is basically four rotations, like that, like that. And if you wanted, you could, you wanted, you could give it an angle as well from that relative to that point. Now these offsets are obviously applied to both the start and the end of the object, but there's an option over here in which you can actually provide offsets without changing the actually finite element definition, because you entered this beam from here to here. So without changing the definition points, you could still give it some relative offsets. These ones also don't change the finite element definition. As to these, none of these change the finite element definition. But the difference between the top 6 over here and the bottom 6 over here is that the top 6 are applied to both the start and the end point, whereas the bottom 6 are applied to, there are different offsets. There are X, Y, Z offsets, which are applied only to the start or only to the end. So, for example, if you wanted to move let's say give a start offset in the Y direction, this Y direction would be the local Y direction of this profile. So if you say 122, the local Y direction, you're giving it in the local Y direction, like that. Get back to 0. If you give the same thing over here, like that, it's going to move in the local Y direction. Whereas if you notice, the other point stays where it is. And by just like I mentioned, the finite element definition stays where it is as well. It's only that for detailing purposes, this part is slightly modified to a new position, whether it's the start or the end. Now, if you wanted to give these offsets, you can do that by using handles as well. So, for example, if I come over this handle, this one which turns into a round circle, there's one which turns into a little tail, not that one. That's the one which will physically move the the frame. But this one, if I click on that one, that's not going to physically move the finite element. It's just going to give an offset. So if I were to say in the x direction, now this is the x direction of my work plane. And if I were to say minus 122 and say move, it's moved in the negative x direction of my work plane. But if I double click on the element, you will see that it has written that number in the local z because it corresponds to the local z of that. So the minus x corresponds to the local z of this beam. If had you given a different kind of a number, for example, something like minus 122 in the x, as well as say a little in the z direction as well, perhaps. So maybe 100 in the z direction as well, something like that. That would be a general kind of a move. In that case, if I were to double click on that, you would see two numbers written in there. So these offsets can be changed, and depending on your requirement as far as your detailing is concerned. Now let's just try to understand them a bit more. Let's just show all and try to understand these offsets in real terms. So for example, when would you use which one? So there's the GERT over here. If I press the Alt D button, I can keep pressing it thrice to bring to the finite element mode, line mode, and I can see that the GERTs are connected in fact to the column. So you see the GERT and they connected, and you see this node as well. So there is a connection over there. But if I want to bring this GERT to the face of the column, a little outside, I would need to know the flange width of that column is 300. So the half of that is 150. So I could double click on that and say, right 150, give it a further offset like that. And now that particular GERT is on the face of the column. But what's nice is that I haven't lost my finite element connection. That's still there. The GERT has just been moved, and I could do the same for the other two GERTs as well. Just put in 150 in there, and my GERTs would then be on the outside face of the column. Now, this particular offset, using these top six over here, as I just mentioned, they are applied to both the start point and the end point. So as you notice, both the start and the end have been moved. But let's talk a little bit about these vertical braces. Now, this situation is such that I have entered it at the top of the beam because the beam finite element line was like that, and it was entered as behind zero, which is the typical way of doing it with floor beams, because otherwise you would not really have a floor. You want all your floor beams to be, so if different sized beams were all entered using middle, like if it was entered with using middle, then you wouldn't really have a floor because all the profile sections would be different, and you wouldn't be able to achieve a flat floor. So you never do that. You always put all your beams in the behind position as far as detailing is concerned. And that means it's slightly different from the finite element model, but that's fine in most cases. But what that also means is that your vertical braces now need to connect to the top of the beam because the definition line is the top. But that's not what I want my braces to, that's not where I want my braces to be. I want my braces to be in the middle of this I-beam. So this I-beam has a height of 300. I want the working point to be 150 millimeters below this point. So what do? I can just use what I just mentioned over there. I can hover over this one, come to that round circle, that one, which you see, that one, and just say in the Z direction minus 150, like that, and say move, and then select this one, select its end offset as well, say move, and now you see that they have come to the middle of the beam with all sorts of weird numbers inside. These are the numbers which are calculated in the local x and y directions of that element. But my finite element model is still intact, as you can see. So these are the ways you use these offsets. You could use, for example, if you wanted to make a connection over here, with the, let's say you had a stiffen end plate connection, and you saw that this is going to be a clash for this horizontal brace member. What you could do is you could give it a shift without really changing the finite element model. You could just select it, hover over this handle, and in the this is the negative x direction as far as the work plane is concerned. So you would just say minus 100, say 10 centimeters, like that, and the other one could be moved in the opposite direction, 100 in the opposite direction. And by doing this little trick, you would have slightly shifted your brace without actually changing their finite element connectivity, which is very important. So that was basically an explanation of how you would use the first page of this dialog box. Coming to the general definitions, you see that every frame object has a name. You can change it, but it's typically given according to what you've created, but you can obviously modify it. It has a beam group, which means that it can be either a beam or a horizontal brace, a vertical brace, a girth, a purlin, a truss, stringer, handrail, column lacing, crane girder, lots of options you have. And finally, those are the options that you have. And by giving those options, you basically allow COMOSYS to intelligently understand what kind of an element this is. And this will help you with many technologies like IntelliConnect and IntelliClone. So it's always a good idea to use. It doesn't really make a difference as far as the finite element modeling is concerned. It does make a difference from the design point of view, but generally from modeling, you can leave it at any beam group which you want, and you'll still be able to do your modeling. But it's a good idea to ensure that your vertical braces are marked as V brace, your beams are marked as beams, and your columns are marked as column. So make sure that you get your beam group right. Now, after the beam group, we have the material. You can change the material of the section. The material, if you want any other material which doesn't exist over here, you would need to go to your, I think, the edit menu. On the right-hand side, we have materials over here. You would need to go in there and add any material which you needed. But that's basically where they turn up over here. There's something called usage. It can be important, especially with plates. With profiles, it's usually, if it's steel, you just leave it at structural steel. It can be precast or cast in place concrete, depending if you've got a rectangular profile or a concrete profile. You can change the usage over here. So I'm not going to talk much about that. The discipline is basically a filtering mechanism. If you want, you can put this as structural steel or concrete or architectural or mechanical. So this profile could belong to your mechanical equipment. So it's a classification. It's a way to filter. You could give it a custom color. By default, COMOSYS will give a different color to each beam group, but you want to override that, you can do that as well. You can give it a class. You can give it an annotation, which means what kind of, if you want to see something written on the screen, that's a separate topic. I won't get into that. Some user-defined fields, and basically that's it. Then you come to your detailing definitions, and we have something called we have these are the most important fields over here. Your part numbering and your assembly numbering prefixes, the start numbers and the actual numbers. The actual numbers will be 0 before you do numbering, and when you do the numbering, you will see some numbers over here, and you will also see a timestamp of when this part was last numbered as a part, also as an assembly. Let me see. There's parent ID depends on whether this particular object is a part of a super object. This is usually mostly used with rebars, but in general, the principle, this variable is given over here as well. This is the capacity ratio. It's got a shear capacity ratio and an axial capacity ratio because it's a beam. Usually beams have loads inside them, because after the analysis, we know the end loads or the maximum end loads. And what you can do is you can convert those end loads into a capacity factor. So that says a capacity factor would typically be between 0 and 1. And if you say, for example, 0.5, this would mean that this element would need to be designed with half the shear capacity ratio of the shear capacity of this element. Whatever connection you're making, it's a shear connection. It should take half the shear capacity. This is for simple beams. And there's of course, simple beams can occasionally have axial forces in them. So you could have let's say 0.1 of the axial capacity as an axial force. Well, this would be in cases where you have the analysis is not done, or the model is not locked, but you know the forces, or you've opened up the lock, so you've lost the forces, but you've converted those forces into maximum shear capacities. Behave as top chord, bottom chord. This is something which is useful when you're detailing trusses. And when you're detailing a truss manually, you want the top chord to behave as a top chord, and you want the bottom chord to be set as behave as bottom chord. And what that basically does is it's got nothing to do with the ability to detail it. It's everything to do with getting a clean drawing. So if you want clean drawings of trusses, you make sure that the top chord is marked as top chord and the bottom chord is marked as bottom chord. In this case, it's just a beam, so it doesn't really matter. These are related to information, whether you want the connections of this thing to be bolted or welded. It won't be very useful perhaps with beams, but when you're talking about trusses or braces, you might want the program to know whether you want the connections to be bolted connections or welded connections. And when you're using IntelliConnect, those kinds of technologies can use this information. Or if you leave it at auto, it can try to make an intelligent guess for you. A directional constraint basically means that when it's doing auto adjusting with trying to ensure that the center of gravity lines are coinciding. This is especially useful when you're dealing with trusses, etc. Whether we want this element to be fixed, which means don't play around with it, because I want this exactly where I've left it. But if it's variable, it would mean that you can play around with the little shifts to ensure that the gravity lines are matching. Exclude from dimensioning means this element, you don't want this element to be part of the numbering process. And do not annotate means you do not want this part to be annotated in the drawings. So it will get a number, but let's say you keep this open, which means it is a part of the numbering process, but still for some reason you don't want it to be annotated. So you can say do not annotate, and in that case it will not be annotated. Formwork group has to do with concrete elements, how they're brought together and unioned into a monolithic piece. That can be explained in some other video. But for the moment, I think this is enough. So I wanted to focus on the geometry tab, the definition, general definitions, and the detailing definitions. The rest, as you can see, are related to analysis and design. So these three tabs are related to the design variables, which is a different topic from what I have in my mind right now. And these two are analysis related variables, stuff like whether they have end releases, etc., or the variation of the I22 and I33, etc. And the design one would have things like whether you want to do lateral buckling checks, or whether you want to force this section, or which design restriction you want to use, how many design points do you want, whether it's a cantilever or not, and if you want to override certain unbraced lengths. So these are all design and analysis related, but the detailing related ones are geometry, general definitions, and detailing definitions. Or if you choose the twin or built up, then you'll have an extra tab coming up over here saying either twin or built up, which you can then use to modify that section.